Hey guys, welcome back to the next video. In this video, we are going to talk about Kubernetes mastering storage. Now, as this is the first video going to be on your session, so this is going to be introducing you to the architecture diagram of the storage. We have different storage, architecture in this one video, which I'm going to make. And the first one, we are going to look at this one over here. So this is the host. As you can see, it could be a worker 1 or worker 2, which is hosting this container. And as you already know that the container has an operating system within itself. So it has the actual file system, which is for the container. So now you must have, seen that on the previous hands-on session when we did a exec an interactive mode. When we log into the container, you will see a folder structure just like a normal Linux file system. Now, this Linux file system is a mimic of what you have in terms of your local host operating system. So your host slash drive, which the particular GB you have on a slash drive, is all mimicked inside your file system. So when you increase the storage size of your file system, it's actually increasing your host file system, because it doesn't really comes with a different file system altogether. So it utilizes the same as the host file system. So this is one concept which will never change for the rest of the architecture. So it's obviously going to mimic what you have on your host file system on your Docker container. So it's not going to be exact the same file system will be appearing, but then it will be using its own directories, and that will be stored in a location offline. And here there is a temp file system over here. So now by default, Kubernetes mounts a volume. Okay, so that's something which no one tells you that. But when you create any kind of a pod or deployment or whatever, the container is going to create a secret volume. Okay, that's basically has your secret, your CA certs, and other important configurations which the container may need for the kubelet to connect and run. So that is already exported, and that's already part of all the pods which you have created so far in our class. Okay, we must have seen it when we described it, but then I didn't explain it to you because I wanted to wait for this video or this session to explain you about that. So the first video we're going to do on the hands-on is that we're going to look at what the default pod comprises of, and what actually is the the default configuration, default volumes which it gets mounted, and where this is stored, how it accesses. So that's basically what we call it as an empty directory in terms of types. So in the next video, we will be understanding about the different types of your storages and different options of your storages. On that video, we will understand about these different types of ways of holding your data. But then in this architecture, I'm going to make it very simple for you, because I want to give you the basic details, no technical stuff. I just want to give you the real-time how it actually works, so that you can actually understand and picturize how things are going to be. And then later point of time, we're going to add names to it, technical names to it, and then it makes real sense for you to get a proper understanding on this. So that's the first one to start with. It's like you will have this, and this is not repeated across any other architecture, but you have to always remember that there is a specific a file system is completely of your host. So if it's on the worker 1 or worker 2, whichever one the pod gets created, it basically uses that operating system hard disk, whatever is assigned to your virtual machine. So that will be assigned as part of your file system, but you will not find the same files as this one and that one, because it will be creating its own location, but that location, the base location, will be stored in your host hard drive. That's the first thing. Second thing is that you're going to have this temporary folder which gets by default. All the pods will be getting this, so don't worry about it. I'll show you that on the hands-on video, the first hands-on video. And then on the next one, we have option of mounting a separate a file or a folder from your host operating system separately from all whatever I told you here. Okay, so this is the third one, addition to this existing ones which you cannot change. You're gonna have an extra one over here, which is basically there are two ways of mounting an hard disk drive into your container. So you can actually share that in terms of the host folder. You can put a host folder directory and say like either you can share a file or a folder, and these shares can happen in read only or rewrite method. So do remember, by default we'll be using rewrite method, but then you have to think whether should you be okay with the read only, because it's always safer to give read only when you are taking content from the host. And do remember, when you are giving such content, you need to make sure that the worker 1 and worker 2 has the same content, because when you are working with a distributed environment and you are taking the content locally from the particular host, then you have to think about synchronizing these contents, because when you create replicas, it means that your application is going to pick up the files from the local system. So that local system file needs to be synchronized between all of them. If you have different versions on these two systems, then obviously the people who's going to receive that will be receiving in two different ways. So those also you need to consider as an overhead for you to maintain the same files across all the worker nodes. The next architecture talks about two containers sharing a similar file system over here in read-write, wherein which both of them are reading and writing data over here. So you can see that read-write means you have two arrows over here, so which means that both are reading and writing data. And here it is a shared partition, which is basically shared by these two containers under one single pod. So now all we are speaking about so far is the sharing of file system within a pod, which means that within a single YAML file. So when I create a single YAML file, I'll be having the volumes created for them, and whatever the containers, either it's going to be a single container inside a pod, or if it's going to have two containers or more than two containers inside a pod, it's going to apply for those. All right. So now going back to the next one, here is this situation where you have two pods over here and which has a container each. And the file system over here is being shared to something called PVC. Another one is called PV, which is below that, or which comprises of that. Now, PV is called a persistent volume. And from a persistent volume, you will be able to claim a specific volume of data that is called persistence volume claim. Awesome. So this is basically what I want to tell you in this video. And you can see in this particular method, we are actually using something called a pod level sharing. As you can see over here, both the pods can actually get the content of this. Okay, so now in here we were talking about the pod level, but then a single pod. So you will have a pod over here and pod over here. So these are different scenarios. But here, when you're talking about multiple pods sharing the similar resources of the file system, so you're going to use this kind of a method right now. And this is much more feasible, and it is also, there is good persistence over here in terms of data which is getting updated. So you won't be losing the data. We will see that on a separate videos on how the persistence volume work, and then how you can do the persistence volume claim for that and access that through your pods. So we have suitable examples I want to show you so that I can explain you much better. Thank you again for watching this video. I'll see you on the next one.